Mutations in lamin A can cause a whole range of diseases, including dilated cardiomyopathy, where you see a thinning of the left ventricle and loss of cardiac function. Individuals that have this disease, they get progressively worse, and they die in their 30s and 40s of sudden heart failure. And there's really no therapy for them. What we found is that a certain cellular pathway, the TOR pathway, gets turned up in the mouse model for this human disease. And that's interesting because there's a drug, rapamycin, that specifically targets TOR and can turn down the pathway. So essentially what we're doing is correcting a normal defect that happens in this disease. And by correcting it, we can reverse some of the cardiac pathology or slow it down, and also dramatically extend survival in this mouse model. The reason this is exciting is rapamycin is a clinically approved drug. Now, it has side effects, but it's used already in rare forms of kidney cancer and in other consequences. And so it's a manageable set of side effects. And when you have individuals that are dying from a dilated cardiomyopathy, then it's very interesting to think about whether rapamycin might be a beneficial therapy, and moreover, whether we can develop analogs of rapamycin which have equal or better efficacy and reduce side effects, and we're very actively involved in that. We can do echocardiography on mouse and measure a whole range of cardiac parameters, and they all get dramatically worse in this mouse. These mice have a very severe defect. They die at about 7 weeks of age. So they look relatively normal at 1 to 2 weeks, and they rapidly develop cardiac defects and skeletal muscle defects, and then they die quickly. What we found is that with rapamycin, we can extend survival out 60% longer than normal. So they live to about 12 to 13 weeks. So it doesn't completely correct the problem, but it slows down the defect in a relatively rapid onset model. Yeah, the humans don't have the knockout of this gene like the mice. They have point mutations, and so they have a slower onset of disease. So it's our hope that if it works in this severe mouse model, it'll also work in the somewhat less severe human disease patients. So that's why we're excited about it.